All right, next booklet in exponential functions is on solving exponential equations. So we have some sort of equal sign question where we have x in the exponent or possibly x somewhere else in the question. The main goal of this question or this concept is to get the same base across the equation. Okay, so I want to get the same base everywhere across. So right now I have 2 on the left and I have 32 on the right, but 32 I could change with a base of 2. So I'm going to rewrite the left-hand side, but I'm going to change the right-hand side to be 2 to the power of 5. As soon as I get 32 into the same base as the left-hand side, so we've got 2 on the left and 2 on the right, I double check to see if there's any work to do in the exponent, whether it's multiplication or maybe some sort of product or quotient rule from grade 9 math. There's nothing to do there right now. So the 2's will actually disappear and you're left with x plus 1 equals 5. Because at this point, the bases are equal, which must mean that their exponents are equal as well. And x equals 4. So that's example 2. Do a couple more for you guys in the booklet. Let's take a look at example 4. So we have 3 to the x times 27 is equal to 81 to the 2x minus 1. On the left side, we've got 3x times 3 cubed, so we want that base of 3, equals 3 to the 4 to the 2x minus 1. On the right side, we have 3 and 3 is the same base. They are getting multiplied together. However, you can't go 3 times 3 equals 9 because of their exponents attached. So instead, they share the same base, which means we're going to rewrite the base and add their exponents together. 3 to the x plus 3. On the right-hand side, we have 3 to the 8x minus 4. So that 4 value multiplies through because it's an exponent to another exponent. So on the right-hand side, we had the power rule. And on the left-hand side, we had the product rule. Okay, remember those rules mean that we add the exponents on the left and we multiply the exponents on the right. 3 and 3 are the same base, so I can make their exponents equal to each other. I'm going to move the x over here, the negative 4 over there. I get 7 equals 7x. So x equals 1 for that question. Same base, apply some exponent rules, and then solve from there. Example 5, 4, 2, and 2 must mean we have 2 across the board. So 2 squared to the x plus 1 equals 2 to the x. And then with this square root 2, I'm going to change that to be 2 to the 1 half. This rule is going to apply to a bunch of our questions moving forward. So you may want to write down that we have this old radicals rule, that the base of the radical is the same thing as the denominator in the exponent, and the exponent inside the radical is the same thing as the numerator on the new exponent. So square root of 2 is an invisible 2 root with 2 to the 1 on the inside, so 1 goes there, 2 goes there. On the outside here, we have 2 to the 2x plus 2. Here we have the same base of 2, and then x plus a half. Okay, they multiply, so we add the exponents. Exponent to another exponent gets multiplied there. So we get 2x plus 2 equals x plus a half. Move the x over, move the 2 over. I get x equals 1 half minus 2, which is negative 3 over 2. 6 has a negative exponent, so I'm gonna, or it's on the denominator, so I should apply a negative exponent to bring the 3 back up to the numerator. So I'm gonna go 3 to the negative x minus 1. Look at the brackets on the binomial there. And then 3 to the 4 on the right-hand side. So I get 3 to the negative x plus 1. Applying a negative here goes to the x and the negative 1, which equals 3 to the 4. Negative x plus 1 equals 4. Move things over, and you get x equals negative 3 in that question. All right, one last example for you for this video is I'm going to do example 7 as well. Okay, another negative exponent where we go 3 to the negative 3. On the right side here, I'm going to get 3 to the x squared plus 4x times 3 to the 1. I know these are all going to be the same. I just have to add these exponents together. So let's cancel everything right now. Get the negative 3 here. X squared plus 4x plus the 1 on the right-hand side. I get 0 is equal to x squared plus 4x plus 4. At this point, I see an x squared value. Now that I have everything over to one side, make it equal to 0. The reason I did this is so I could factor solve the question. I get 0 is equal to x plus 2 times x plus 2. If I had two different brackets, I'd make them both equal to 0. These are the same though, and they both get me an answer of x equals negative 2.